We're talking about your traditional IPsec modes. It has around two modes. Okay, one is called tunnel mode. Second is called transport mode. Very simple. Imagine that I have a PC here. We're talking about your traditional IPsec modes. It has
to
around
another router,
two modes.
another router.
Okay. One is called tunnel mode.
PC2.
Second is
We have
called
PC1.
transport mode. Very
Then we
simple.
got PC2.
Imagine that I'm
I'm running
PC
tunnel
here.
between
We're talking about your
R1
traditional
and
IPsec
R router.
is PC1, tunnel source IP is my router. Now, if actual data source and tunnel source are different, then it is called as tunnel mode, where you encrypt the entire original IP packet and you're adding a new IP header itself as a new header. So, entire IP address, everything will be hidden inside the tunnel or IPsec header. Talking about your transport mode, your actual source is also him only. So my data is created by him as well as tunnel is started here only. So this encrypts and authenticates only the packet payload. This mode does not provide any sort of overlay functions. Okay. So here on top of IP header, I don't have anything because your tunnel starting point and data starting point both are same only, guys. There are two things. So here you can see a simple diagram. So here you can see a transport mode, a tunnel mode. See tunnel mode. I'm having original IP is getting encrypted inside my IPsec header. Okay. But here in transport mode, your data is only encrypted. Your original IP address still maintained only. Okay. So both the way I'm giving example using ESP only. Okay. Anyways, I use ESP or AH. Diagram will be similar. Okay. No difference at all. Okay. Now talking about transform sets. So this might be confusing if you're seeing for the first time. See, transform set means what? Well, understand this. See, in simple definition, I'll give you transform set, or some people I call it as TR set. It's a combination of security protocols and algorithm that defines how data will be protected inside an IPsec tunnel. Imagine you're locking your home. Okay. In my home, I have the main lock, I have fingerprint, then I have a dog also inside. So I have three different mechanisms. Similar way for this one, for AH, I use AH, MD5, HMAC combination. So now I have three-layer security. I have the main lock outside my house, then I have a fingerprint lock, then I have a dog also. In similar way, in a transform set is a combination of security protocols and algorithm that defines how data will be protected inside your IPsec tunnel. Now think of it like a security recipe. It tells router what are the protocols or what encryption, authentication, integrity combination you have to put for protecting my data. So it has encryption algorithm using AES DES 3DES. For hashing, we use SHA or MD5. Hashing as well as integrity, we use SHA or MD5. And for IPsec protocol, we use ESP or AH, both the way, either AH or ESP. So same will be repeated if you see carefully. MD5 HMAC, SHA HMAC, SHA HMAC, SHA HMAC, SHA HMAC. Different variations are there. In ESP, we have AES, DES, 3DES, null also we are having. See, a transform set basically tells how do I secure my tunnel. Example, I will use ESP for encryption. I use AES for data hiding and SHA for integrity. In the lab, I will when I configure the actual lab now, on that lab you can see I'll be doing all these things. I'll be using one of these combinations only. Okay. So let's talk about now IKE, Internet Key Exchange. See, IKE is a protocol that performs authentication between two endpoints. One of the very most important topic, okay, this IKE concept under IPsec. Let me just read it, what I've done here. So IKE is a protocol that performs authentication between two endpoints to establish security association, also known as IKE tunnels. Now these tunnel carried control plane and data plane traffic for IPsec. What do you mean by that? See, IKE is simply a protocol, guys. Okay, it's a protocol. So we have protocol. So IKE is a protocol that automates the setup of an IPsec tunnel. This is going to handle authentication between two peers. It will do negotiation also of security policies. It takes care about key exchange for encryption too. See, without IKE, you have to do manually everything. So in simple word, IKE is like a handshake. Before before starting to send data, before starting to secure my communication, it makes sure both router are trusted one. Okay, so we have two phase. One is called phase one, second is called phase two. If you are studying for the first time, it might be confusing. I would recommend you to please look into the official book, read line by line on IPsec to understand these concepts more clearly. Okay. Talking about your IKE phase one, it's also termed as establish secure channel. It's like your management tunnel. The IKE phase one is like management tunnel. See, the goal of my IKE phase one is to build a secure control channel between the peers. So they can talk safely before even sending my data. Now, what happens in IKE phase one? See, first of all, peer authenticates each other. Okay. They agree on which algorithm to use. Should I use which encryption, which hash, Diffie-Hellman group, lifetime I'm going to use, all these things. And also, we create bidirectional secure tunnel. The tunnel I'm creating, right, that is termed as ISA-KMP. ISA-KMP. And this has two different modes also. We have main mode and aggressive mode. So let's see what are the terms, what are the things I'm exchanging. Here we are exchanging all these things. Data encryption DES, triple DES, AES, MD5, SHA, Diffie-Hellman group, that's used for asymmetric key exchange. We have RSA signatures, that's for digital certificate. Or else I can also use pre-shared key, which I spoke last time also in the class. Talking about your IKE phase one or version one, like here's the phase one. I told about the main mode, right? In main mode, it consists of 6 messages. Main mode 1, 2, 3, 4, 5, 6. So the main mode 1, this is the first message that the initiator sends to the responder. And this will carry all the information. What are the things I am supporting? What hash algorithm? What encryption algorithm? What authentication method? What DH group? All these things will be there in the main mode 1. For the MM1 message, the responder will respond back with MM2 saying, I am supporting all these things. You can match. So MM3, in this message, the initiator will start the Diffie-Hellman key exchange. For that, the MM4 will respond back. In MM5, the initiator starts authentication by sending the peer router its own IP address, and for last, the MM6, they will respond back. This might be confusing before you do the lab, but once you finish your lab, it will become more easier. So please write this down on a paper or notebook. So your main mode used for site-to-site VPN, and it has 6 messages exchanged and it is more secure. Then we also have something called aggressive mode. So in aggressive mode, it is used for dynamic and remote access VPN. Please remember this, your main mode, it is used for site-to-site VPN. Your aggressive mode is used for remote access VPN. And it has only 3 messages. It is like more faster and it is less secure. So in 3 message, I send one shot, MM1, MM3, MM5 in one shot. That neighbor guy will reply in one shot. They will be authentication completed. That's it. So in the lab also we'll be using this. Talking about IKE phase 2. See, phase 2 is like creating your IPsec tunnel, your data tunnel. Using phase 1, what I did, we created management tunnel. It is like putting a road first. Second, we have the second message called phase 2 that uses something called data tunnel. And the goal, it is use the secure channel from phase 1, which I created to negotiate my IPsec parameter for actual data to be transferred. Now what happens here? See, your peers will agree on which IPsec protocol I should be using. Now I will decide whether I'm going to use AH or ESP and which algorithm I'm going to use. Is it AES, SHA, etc. and all. And here, 2 IPsec essays will be created. 2 IPsec security association will be created, one for each direction. And exchange keys for encryption. Now you might be thinking, your phase 1, it was bidirectional. Why it is phase 2, one way, 2 unidirectional? See, when you are trying to form a tunnel, right, secure connection, to check the entire road, I have to check in both the way in one shot, both going and coming of traffic. But when you try to encrypt data and send, right, I can encrypt only one way path, maybe like when data is going from my source to destination, at that time only I want encryption to happen. But reply, I don't care about it. So there is a one way only I do encryption. Like that we can decide, right? So that's why in phase 2, they create 2 unidirectional tunnel. One this way and one this way, separately. Even this way tunnel is down, no problem. I have the forwarding tunnel up always. So he create. I'm going to create 2 IPsec essays and exchange keys for encryption and all. And here we decide transform set, crypto map, access list and all. And now my data will flow securely. Here also we use quick mode 1, quick mode 2 and 3 messages. Talking about your version 2. See, you have 2 versions. One is version 1, phase 1, phase 2, version 2. In version 2, the first exchange will carry all the information to make sure he's the right person to exchange tunnel information. In second exchange, I authenticate the entire tunnel itself. So here, a lot of people sometimes they get confused using these keywords. That's why I'm telling again. Please read through Brooks once again because these terms are pretty new for you. Okay. So I'll simply explain the version 1 and version 2 difference, IKE. See, your IPsec uses internet key exchange for what reason? To create secure VPN tunnel, right? And there are 2 main versions. One is called IKE version 1, which is older version. Now, latest version is IKE version 2. So in IKE version 1, it works in two separate phases. Phase 1 to build the ISA KMPSA. Phase 2 for building IPsec SA. Phase 1 is to put that road first of all. Phase 2 to decide whether my vehicle can travel or not, or to check whether it is safe or not. So in modes, in phase 1, we have main mode, then we got aggressive mode. Okay. Talking about our IKE phase 2, this is a modern and efficient version. So here we have only one phase, simplified and even faster, which combines phase 1 and phase 2 in a single negotiation message. I'd always use only 4 messages for tunnel setup. Okay. So it's very easy, very fast. It supports NAT traversal also. It has NAT-T support. So to understand more, again, I recommend to study from book because of these new words. Okay. Okay. Now establishing an IPsec tunnel between two routers. We'll do a simple lab. Normally in internet or anywhere you do the labs on this IPsec VPN, they will build an entire bit topology and that might be very confusing. Okay. Here I'm not going to play around in establishing an OSPF connection or BGP connection, all these things, no complications. What I will do, I'll simply take two routers, I'll configure IPs, then I will configure IPsec commands between them just to establish tunnel between R1 and R2. See, if you have R3, R4, R5, R6, and if you are trying to connect R1, R6 tunnel, same commands are there. Make sure you have reachability between R1 and R6, like using OSPF or some other protocol. Okay. So let me open this GNS3 for lab purpose. Let's develop one lab as I informed you using a two simple router, not more than that. So I'll just take one router called C7200, one more router, and I connect them using a cable. First, I'll configure an IP address. So once that I'm going to use 12.001/8. Here 12.002/8. Next 12.001/8. 12.002/8. That's my R1. That goes my R2. Oh, sorry. Both I opened R2 and R. Please check out the number above. So R1 is here and R2 on the right hand side. Okay. No. So I just gave 12.2 IP address on R2 and on R1 I'm gonna give IP address 12.001. I'll just check whether I can ping my neighbor or not. That's it. So you have to imagine as if I'm having network behind the scene of R1 and some network behind the scene of R2. So first, let's define IKE phase 1 on both R1 R2. So for that, I will say crypto ISA KMP. I'll add a policy. In this policy, I'll give a policy number also. In this, I'll define what encryption mechanism I'm going to use. I'm going to use AES. What hashing algorithm I'm going to use? SHA. Authentication, I'm going to use pre-share. Diffie-Hellman group 2. And lifetime is not required, but just mention how many seconds tunnel has to be up. 86400. Same command, you have to do it here also. Just for simplicity, I'll copy paste it. This is the command. Same command, just copy, go to R2 and paste it. That's it. Finish. Next, we have to define the pre-share key password. Let's define the password. So I'll say crypto ISA KMP key is CCNP123. I'm sorry. With whom I have to exchange this key? With 12.002. What happened? Sorry. Address 12.002. With whom I have to exchange the key? I mentioned that here now. Now going with R2, same. I'll say crypto ISA KMP key CCNP123. With whom I have to exchange the key? Address, what address is 12.001. Correct. Now we have to go with the transform set. Very important command. So here we will define the actual data has to be protected by what. So the command will be same again. Let's create it now. Crypto IPsec transform set. I will say TS1 as the name. ESP AES method. Put a question mark. You can see a lot of different options. I'm using ESP, SHA, then HMAC. That combination I'm using it. Okay. Make sure same in R2. No difference. So crypto, IPsec, transform set, TS1, ESP AES, ESP, star, HMAC. Simply. Okay. So far it is clear. Now we will need to create the crypto map. Okay. So we have to bind the peer with the help of transform set and ACL together. So as of now, I am not using ACL because ACL will be used when I have my site IPs here. I just use the word, but if you have IPs which need to be going through the tunnel, only those IPs will match. Let's map it now. So crypto map, I'll go to R1, crypto map, name of map, CMAP, 10, IPsec, ISA KMP, here, set peer as 12.002, to set transform set, call that TS1 here. And here, if you have an IP address set which you want to go through this tunnel, you have to write ACL with this number 101. Like access is 101. Provide the IPs which you want to go through tunnel, so that not all traffic will should go to tunnel. Then we'll go with crypto map, CMAP 10, IPsec ISA KMP, set peer as 12.001, set transform set as ts1, then you have to match the address as 101. Now, at last, final stage, we have to apply crypto map to my interface. Which interface? FA0/0. Last simple command. Interface FA0/0. Crypto map CMAP. That's it. Go here also and tell the same thing. Interface FA1/0. Crypto map. Crypto map CMAP. That's it. Now wait for tunnel to up. See, immediately my tunnel came up. Now I can go back to R1. I can verify tunnel. Show crypto ISA KMP SA. So wait for some time. This tunnel will be up. IPsec SA. So once it is up, this will also come up. Let's try to ping first of all. Ping 12.002. Okay. Now I told you, right, I'm going to create an ACL, right? So what I will do, just for the showing the source IP address, I will go ahead and create a loopback IP on R1 to act it as a source. So interface loopback 0 IP address is 10.1.1.1 255.255.255.0. Here I will go ahead and create one more IP address. Interface loopback 0 IP address 10 dot sorry IP address 10.2.2 255.255.255.0. Should I use what here? Yeah. Done. Okay. So as of now, R1 has a loopback IP, R2 has a loopback IP. Let's write an ACL between them. Access list 101 permit IPs which are like 10.110.000.000.255. Then 10.2.0 2 dot I think I just missed something. Let's expand this command. Let's write again. Access list 101 permit IP 10 dot 10.1.1.0 255 10.220 255. Subdefining from where to where tunnel should be happening. Okay. Access list 101 permit IP 10.2.0 255 10.110 255. That's it. If you want to check, type show access list. It will show you. Correct. So let's see tunnel first of all. Show crypto ISA KMP SA. It is still showing down. Let me quickly verify the command I ran. CCNP 123 on R2. CCNP 123 with R1, R2. Just give me a second. I'll just check what is the issue. Okay. But once I fix that, the show crypto ISA KMP, see IPSA KSI is up now. Here you can see. Okay. So the issue I was facing is that one side I was half duplex and one side was full duplex. And once I fixed that issue, it has been fixed. Okay. So fine.